is going to be September 13th. Okay, so this is for our September 13th, 2017 test for Geometry Pre-AP. So number one, an exact location in space with an indefinite shape, which means we can't identify the shape, and an indefinite size, and that is a point. Remember we talked about the point as being kind of like the building block of geometry, kind of like cells for biology. So a point, a single point, we label it with a letter, capital letter. It has no definite size. It has no definite size and no definite shape. We just know it's a point, and that was what we use for the reference for geometry. So let's look at the next one. An object with no thickness that extends infinitely in two directions. So we're looking at an object with no thickness that extends infinitely in two directions. And that, of course, is going to be a line. And I'm just going to kind of give you a basic line here. So that's going to be a line. Now, when we name a line, remember, we can name a line with any 2 points that are on that line. So I could call this line AB. Remember, this is the line symbol. Or I could call it line BD if I wanted to. Or I could call it line BC or line CB or line DA. Doesn't matter as long as I'm just picking 2 points, because remember, any 2 points determine a line. Okay, so let's look at number 3. Number 3, part of a line consisting of 2 endpoints and all the points in between. So it's the part of the line, 2 endpoints, that's key. End means they end. And all the points between. That means in between those 2 points. So the picture they're describing would be this. So this would be segment, PQ. So this is a line segment. A line segment is a piece of a line. It's actually something that we can measure. It's measurable. I can actually take a ruler and measure how long a line is. A line segment is. I can't measure a line. A line is infinite. You can't measure infinity. But a line segment actually has 2 ending points. It has 2 endpoints, so it stops. So we can measure it. And the symbol for a line segment looks like this. You pick the 2 endpoints. Let's say I've got a point in between those 2. When you name this segment, you still only use the endpoints. If I'm talking about the entire segment, it's PQ or QP. If I wanted to talk about all the segments present, then I could have segment PR, segment RQ, and segment PQ. But I just want the main segment right now. So that would be segment PQ, or it could be QP. All right, for our next example, we have number 4. Part of a line consisting of 1 endpoint. Again, this is part of a line. 1 endpoint and extending infinitely in one direction, just like the band, all the girls' favorite. So when we're describing this, we're talking about a ray. And this is kind of what a ray looks like. This is a ray. An array basically has 1 endpoint and extends infinitely in another direction. So this one would be ray MN. Now, we cannot call this ray NM. Remember, the ray, when we name it, is starting point has to be listed first. The second point has to be the point that it's going through second. So let's say I give you another ray, and this ray is going this direction. That would be ray TS, not ST. This ray starts at T and goes through S. And remember, the symbol, when we do the symbol, always points to the right. So that's rays. Okay, so let's look at number 5. Number 5, we're looking now at rays that share a common endpoint but continue infinitely in opposite directions. And that gives it away right there. Those are opposite rays. Okay, opposite rays start at the same place. Okay, so we'll call that point E. We're going to draw one ray this way. So we'll call that EL. And then we're going to draw another ray this way. And we can call that ray EB. If I were to separate those, you would see that these 2 opposite rays are ray EB and ray EL. Notice they have the same starting point, E. And what you notice is two opposite rays actually will form a line. But they have to start at the same point and go opposite directions. These are not opposite rays. Those are different rays, but they're not opposite rays because they're not going opposite of each other. Okay, so let's look at the next example. A flat surface that continues infinitely in all directions. A flat surface, it's flat and it's infinite, all directions, and that is a plane. And there's a lot of different ways to draw a plane. There really is no perfect way to draw a plane. I'll draw a basic example of a plane because the one that you see a lot, you'll see a plane like this, and you'll have your points in the plane. So we can call this PQR or plane PQR. You put a plane in front of it. And sometimes they'll have an italicized uppercase letter that's not a point, in this case M, and you could call it plane M. Now, using that as a reference, let's go back to the lines. When we talk about the line, one thing I forgot to mention is that sometimes with the lines, you'll have a line that looks like this. And it has just a lowercase letter. That's a Q. We do that in order to alleviate the problem of having too many points and having our picture be too busy. So in that case, you could call this line Q. That's another way you can name a line. Just like with the plane, you can name it with one point. All right, so number 7. If we're looking at number 7, we're looking at points that lie on the same line. So points that lie on the same line. Those are collinear. Now I'm going to expand this. This can be points, segments, or rays that lie on the same line. Any of those can constitute collinear, as long as they're on the same line. So if I were to draw a line here, and I have all these points, pay no attention to what I'm spelling and what I'm choosing for my points. But what you would say here is it would ask you, what points are collinear? Well, you would make a list. T, I, R, E, and D are all collinear. But let's go into segments. Wouldn't segment TI also be collinear? Wouldn't segment IE also be collinear? Those are all on that line, right? How about ray RD? That's on that line. All of these are collinear. All of these points, segments, and rays, because they're all on the same line. So that's what collinear means. Okay. So let's look at number 8. Points that do not lie on the same line. That would be something like this. Here we go. We got A, we got B, and then we got C hanging out on its own up here. These are non-collinear. So instead of collinear, they're non-collinear. And again, this applies to points, segments, or rays, depending on what we're being asked. Okay? Those are non-collinear points. In order to be collinear, we have to be in a straight line, on the same line. You have to be able to draw a straight line through all of them. Okay. 9, points that lie on the same plane. Well, instead of non-collinear, now we're looking at non-coplanar. Oops, sorry, points that lie on the same plane. Those are coplanar points. So if they lie on the same plane, they are coplanar. So if I were to draw a plane, and I had P, Q, R, S, those are all coplanar points. And you would list them, P, Q, R, S. P, Q, R, and S are all coplanar. But again, you can also say segments, rays, and for planes, you can also add lines, because planes extend infinitely in all directions. So I could have a line. I could have line QS right here. Line QS is in that plane. Ray, I could make segment PQ in the plane. I can make any of these in that plane. So that's what coplanar means. Now let's look at non-coplanar. Points that do not lie in the same plane. And again, this is points, segments, rays, or lines that do not lie in the same plane, and that is non-coplanar. Okay, so I'm going to draw a plane here, my standard plane, and I'm going to draw this line that touches the plane right here. It's kind of like, imagine a needle pushing through a piece of fabric or through a piece of paper. I'm going to draw this line that goes through this plane. And this will be M, this will be N, and then we'll have a couple of points. Here's A, and here's T, for example. M is not coplanar with the rest of them because M is not in that plane. Everything in this plane is coplanar except for the M. Any rays, segments, or lines that I draw in that plane are coplanar except for line MN. Line MN is not coplanar with everything else because the only thing that line MN shares with the plane is a point.